Hello everyone, this is another video on electromagnetic theory. Okay, here we'll be discussing important concepts which may come in your GATE exam, right? So, um, first thing, this chapter is called radiation. This is advanced chapter of electromagnetism. Okay, from which two more questions will come. Okay, so from this chapter, the concept that will come are see process of energy in form of energy in form of electromagnetic wave. Okay, so electric like for electric field it will electric field will depend on inversely proportional to r. Okay, uh, magnetic field will depend on this one, inversely proportional to r, and your pointing vector will depend on like will be inversely proportional square of the distance. How? Because as we know is what E cross B by mu naught, isn't it? So E or 1 by r cross 1 by r. So this gives us what? 1 by r square, isn't it? Yeah. So there are some formulas we have to remember from this chapter, okay, which are see electric dipole transition power radiated, power radiated, power radiated by an accelerated charge particle, accelerated charge particle. All right, power radiated by an accelerated charge particle. That will be what? P is equal to mu naught q to the power q square r6 by 6 pi c a square minus v cross a by c whole to the power 6, right? Yeah. Hmm. Okay, this one will be your formula, right? Yeah, and there will be different cases where the formula will vary, right? For example, non-relativistic case, what will happen? Non-relativistic case, power will be equal to mu naught q square a to the power 4 6 pi c. Okay, then comes your relativistic case, which is this one. And for example, v is proportional to a, the velocity is proportional to acceleration, so v is equal to mu naught q square r fourth, okay, r fourth divided by 6 pi c, right? And if v and a are parallel, then what will happen? P is equal to mu naught q square r sixth divided by 6 pi c a square. Okay, these are the formulas that you really need to remember. Right? So let's go to some questions now. The first question: see, when a charged particle emits EM radiation, the electric field E and point vector S are given. Like as the large distance from the emitter varies, so electric field varies as 1 by r to the power n, and pointing vector varies as 1 sorry varies as 1 to the 1 by r to the power m. So what are n and m? We know electric field inverse proportional to r, magnetic field inverse proportional to r. So your pointing vector is what? Your pointing vector is E cross B by mu naught, isn't it? So 1 by r cross 1 by r, that will be 1 by r square, isn't it? So your pointing vector will be what? Proportional to 1 by r square. So your n is 1. I'm sorry, n is 1 and your m is 2. So n is 1, m is 2. See how easy it is. It will come for 2 marks in game, right? Yeah. Next question. See, an electron is decelerated at a constant rate starting from an initial velocity u to u by 2 during which it travels distance s, the amount of energy lost in radiation is. Right. So power radiated is what? Power formula is power radiated. Power radiated is how much? P is equal to d by dt, isn't it? Rate of change of energy is equal to mu naught q square, okay, a square by 6 pi c, right? So E is equal to how much? Mu naught q square a square by 6 pi c dt. That means t, right? If you integrate it, t. Now, okay, now see one thing here. See, this is V is equal to, we know what? V u minus at t. Okay. So here V is what? How much is the V? Where is it? See, this is V u by 2 because changing from initial velocity u to u by 2. So V is your u by 2 and u is your simply E minus 80. Okay, so this comes as minus u by 2 is equal to minus 80. So t is equal to how much? U by 2a, isn't it? T is equal to u by 2a. So put it here. So if you put it here, mu naught q square a square by 6 pi c u by 2a. Alright, next what? Next what? U by 2a. Now, if you simplify it, it will become, if you simplify it, mu naught q square uh, a into u by 12 pi c if you simplify it. Alright. Now again, if you put those formulas, v square is equal to u square minus 2as, we know, isn't it? Okay. Why I'm using minus here? I also wrote v is equal to u minus it, whereas it is plus, because this is a decelerating charge particle. Okay. I electron is what? Decelerated here. You can read the question. Okay. So v square is equal to u square minus 2as. So v is again u by 2 mine is equal to u square minus 2as. Okay. So this is u square by 4 is equal to u square minus 2as. So this is u square by 4 minus u square is equal to minus 2as. Okay. Minus 3u square by 4 is equal to minus 2as. So what do we need? We need a. We need to put in place of a. So a is how much? A is 3u square by 8s, isn't it? So just let's put it. So mu naught q square u by 2l pi c to 3u square by 8s. Okay. Yeah. So if you simplify it, yeah, this will be only, yeah, this is 4, the below part will become 32 mu naught q square a u cube divided by 32 pi cs. All right. Now what we are asked? We are asked the amount of energy lost to radiation. Amount of energy lost to radiation. That means fractional energy we have to calculate. All right. We have to calculate what? This is called fractional energy. Fractional. Fractional energy. So what is fractional energy? E by initial kinetic energy. Okay. So E is how much? E is this one divided by half mu square. Okay. If you simplify it, you will get what? Okay, let me do it. Mu naught q square a u q divided by 32 pi cs divided by half mu square. This cancel will become 16 u square. This is u. Okay. So this one overall becomes the answer. Overall becomes how much? Mu naught e square u 16 pi cs. What is e? In place of q, I just put e because this is an electron. Okay, got it. So see, what I did was, first of all, I have to calculate power. Power is how much? Mu naught q square a square by 6 pi c. We got the energy from it. Okay, energy t, we got the value of t from that equation of motion. V is equal to u minus at minus y because it's a decelerating particle, and we got t. Then again, after this, we have to put in place of a. Okay, a, because a is not in the options. You see, a is not in the options, we have to put a. So from again equation in motion, I calculated A and put there, right? And fractional energy is what? Total energy divided by initial kinetic energy. Okay, yeah. So this is our answer. Next question. A non-relativistic particle of mass m, charge e, moving with a velocity v, acceleration a, emits radiation of intensity I. What is the intensity of radiation emitted by a particle of mass m by 2, charge 2e, mass m by 2, charge 2e, acceleration 2a? Okay. So, what is the intensity of radiation? See, intensity of radiation is what? Intensity of radiation I is proportional to actually q square u square a square sine square theta by r square, right? So see, what is the first non-relativistic particle of mass m, charge e, mass m, charge e, and well, acceleration a is already given. Okay, so for that I1 is how much? Charge e square a square sine square theta by r square. Now the intensity for the second particle will be what? These are the values. So 2e square, 2a whole square sine square theta whole divided by r square, isn't it? R square. Simple. So that is what? 4 into 4 e square a square sine square theta divided by r square. That is 16, right? 16. And this can, we can write what? This is I1, right? So I can write it as I1, isn't it? I1. Alright. So yeah, this is it, I think, isn't it? 4 into 4. 16, right? Yeah. 16 I1. So this is I2. So check the answer. 16, yeah, 69. Okay, because I was the intensity of the first one. So this is your what? 69. Alright. Yeah, these are some of the questions from this chapter, radiation. Okay. If I just revise a bit in the what I did in the previous class. Previous class we just did gaze transformation and all. Okay. So that is also very important. Gaze transformation. That is simple vector potential will be converted into what? Like this. Scalar potential will be converted into phi minus del lambda by del. These are the two have to remember from the previous chapter. Alright, and magnetic field is a what? Del cross A, and electric field is a what? Electric field is your minus del phi minus del A by del T. Alright, yeah. So these are the things you have to remember. Alright, these are the gauge transformations. From there, you can solve a lot of questions that may come for 2 marks. And from radiation chapter also, questions will come for 2 marks. Right? Yeah. So that will be the short session on this chapter. We'll do more questions on AMT in the upcoming sessions. Okay. Thank you very much.